Dear students, under the topic polar coordinates, we are learning about angle of intersection of two curves, and here we have the next problem, problem 6. Already we have completed problem 1 to 5 in our previous video lectures, so kindly visit those lectures and understand this problem better. So here we are going to find the angle of intersection of the curves r equals a divided by 1 plus cos theta and r equals b divided by 1 minus cos theta. By using the trigonometric identity, you can change this 1 plus cos theta as 2 cos squared theta by 2, and when taken to the numerator, you will get r equal to a secant squared theta by 2. In a similar manner, you will get here r to be equal to b cosecant squared theta by 2, and we have already done a similar kind of problem which you can solve in that manner. Or you can also solve it by differentiating this directly also. So let me show the differentiation directly. So let us take the first curve and mark it as equation 1. So r is equal to 1 plus cos theta. So let us mark this as equation 1. Now before differentiating equation 1, we can rewrite it as r equal to a multiplied with 1 plus cos theta the whole raised to the power negative 1, so that I can differentiate it easily. So now we have to differentiate this with respect to theta. So when we differentiate this with respect to theta, we get dr by d theta to be equal to, a is a constant, so a. Now this has to be differentiated by using x power n formula, which is equal to n x power n minus 1. Here the value of n will be negative 1, so it will be minus 1 multiplied with 1 plus cos theta to the power minus 1 which will be minus 2. Again chain rule we have to use, multiplied with, and we have to differentiate whatever is inside the bracket. What is the differentiation of 1? It is a constant, so when differentiated it becomes 0. And the differentiation of cos theta is minus sin theta. So this is how we have to differentiate r equal to a multiplied with 1 plus cos theta to the raised to the power negative 1 by using the chain rule method. So therefore we obtain dr by d theta is equal to this minus and this minus gets multiplied and it becomes plus. So a multiplied with sin theta and 1 plus cos theta raised to the power negative 2 can be written in the denominator as 1 plus cos theta the whole square. When this term comes to the denominator, this negative power becomes positive. So this is dr by d theta. Next we have to find tan phi 1. That is equal to r multiplied with d theta by dr, which is equal to r multiplied with, what is d theta by dr? It is the reciprocal of dr by d theta. So write the reciprocal of this. So the denominator should be written in the numerator. So 1 plus cos theta the whole square divided by a sin theta. But from equation 1, what is r? R is equal to a divided by 1 plus cos theta. So we can substitute that over here. So a divided by 1 plus cos theta multiplied with 1 plus cos theta the whole square divided by a sin theta. So now if you see, this a and a can be cancelled, and one of the 1 plus cos in the numerator and this 1 plus cos theta in the denominator can be cancelled, and we will be left out with, so if one of the power goes, we will have only 1 plus cos theta divided by the sin theta in the denominator. So therefore tan phi 1 is equal to this. But we know that 1 plus cos theta can be written as 2 cos squared theta by 2. We are using a trigonometric identity over here, where 1 plus cos theta is equal to 2 cos squared theta by 2 divided by sin theta can be written as 2 sin theta by 2 cos theta by 2. Again we are using another identity from the trigonometry. So this 2 and 2 gets cancelled. One of the cos theta by 2 gets cancelled, and we will be left out with cos theta by 2 divided by sin theta by 2. But what is cos divided by sin of an angle? We know that it is equal to cot theta by 2. So therefore we get tan phi 1 to be equal to, so on simplifying we get that to be cot theta by 2, and this cot theta by 2 can be written as, so tan phi 1 can be written as, cot theta by 2 can be written as tan 90 minus theta. So tan 90 is pi by 2 minus the angle over here is theta by 2. So this can be rewritten like this, and therefore we get the angle phi 1 to be equal to pi by 2 minus theta by 2. So let us mark this angle phi 1. In a similar way, let us calculate phi 2, for which we have to consider the second curve that is given, that is r equal to b divided by 1 minus cos theta. So let us take and write this curve now. Now let us mark this curve as equation 2. Now we shall rewrite this in order to differentiate it. So this can be written as b multiplied with 1 minus cos theta raised to the power negative 1. Now let us differentiate on both the sides with respect to theta. So differentiating this with respect to theta, we get dr by d theta is equal to b multiplied with, now like how we did the previous curve, in the same way we have to use x bar n formula over here, where the value of n is negative 1. So minus 1 multiplied with 1 minus cos theta raised to the power minus 1, which will be minus 2, multiplied with the whatever is inside the bracket, that also we have to differentiate by using the chain rule. So first the differentiation of 1, which will be 0, because when constant is differentiated it becomes 0, minus cos theta. The differentiation of cos theta is minus sin theta, and already we have a minus here, so minus into minus will become plus, and so we will be left out with only sin theta, and therefore we have obtained dr by d theta to be equal to, this minus we can write, so minus b and then sin theta, and divided by, we can take this 1 minus cos theta to the power minus 2 to the denominator, so that we can keep the power positive. So 1 minus cos theta the whole square. So when this is taken to the denominator, the power becomes positive. So 1 minus cos theta the whole square we have. Now we shall take this and substitute in tan phi 2. So we know that tan phi 2 is equal to r multiplied with d theta by dr. So that is equal to r multiplied with d theta by dr is the reciprocal of this. So reciprocal we have to substitute here, which means the denominator we have to write in the numerator, which is 1 minus cos theta the whole square divided by, the numerator goes here to the denominator, so minus b sin theta. But what is r? From our equation 2 we know that r is equal to b divided by 1 minus cos theta. So let us substitute that over here. So b divided by 1 minus cos theta multiplied with this negative sign, let me write here in the front, multiplied with 1 minus cos theta the whole square divided by b sin theta. Now if you see, b and b gets cancelled, and one of the 1 minus cos theta gets cancelled, and after we cancel that we are left out with 1 minus cos theta divided by sin theta. Now again we have to use the trigonometric formula over here, where we know that 1 minus cos theta can be written as 2 sin squared theta by 2 by using the trigonometric identity, divided by sin theta can be written as 2 sin theta by 2 multiplied with cos theta by 2. So 2 and 2 gets cancelled, one of the sin theta by 2 gets cancelled, and we are left out with sin theta by 2 divided by cos theta by 2. But also remember, this negative sign has to be carried out throughout, which I have left in this step. So let me write, so negative multiplied with this, so you have a negative sign, and so we have a negative sign over here, and therefore what is sin by cos? It is tan, so we get minus tan theta by 2. Therefore we obtain tan phi 2 to be, so we get tan phi 2 to be equal to minus tan theta by 2, and so this can be rewritten as tan of minus theta. So minus tan theta can be written as tan of minus theta, and because here we have theta by 2, this can be written as tan of minus theta by 2. Now comparing the left hand side and the right hand side, we get the angle phi 2 to be equal to minus theta by 2. So therefore we have got phi 2 to be minus theta by 2, and we also obtained phi 1 to be equal to pi by 2 minus theta by 2. Now let us find the angle of intersection between the two curves, which is xi, that is equal to phi 1 minus phi 2, which is equal to, what is phi 1? Pi by 2 minus theta by 2, and phi 2 is minus theta by 2. So phi 1 minus phi 2, minus of minus theta by 2. And so this will be equal to pi by 2 minus theta by 2, and minus of minus is plus theta by 2. And this gets cancelled, and we obtain the angle xi to be equal to pi by 2. So therefore we have obtained xi to be equal to pi by 2. So therefore the angle between the given two curves is equal to pi by 2, that is 90 degrees, which means the two curves cut orthogonally. So hope you have understood this problem. Thank you.